Hi guys, in this video I'm going to be working through an example problem that deals with the bank account. Remember, if you haven't watched the first video of this series about where I kind of walk you through the formula and what all these letters mean, that's going to be pretty important, so I would suggest you go do that first. The problem says this: you invest $5,000 in a savings account and earns 2% simple interest, and you leave it there for 7 years. We're going to assume that you don't add any more money to it over those 7 years. You just throw some money at the beginning and you let it go. And the question is, what's the value of the account there after 7 years? How much do you have in that bank account? So let's go through and just identify some quick stuff. See, that $5,000 is going to be pretty important. That's how much you put in. So we call that the principal. The principal in this case is $5,000. It's a savings account. It earns 2% simple interest. So that 2% is our interest rate. And remember, that's 2%, but we're going to enter it in as 0.02. That is going to be extremely, extremely important that we don't put 2 in, we put 0.02. If you put 2 in, you're going to be like a millionaire off of this thing, okay? The interest is called simple interest, and your job is to understand that means we're going to add interest one time every single year. That means that n is going to be 1 in our formula. We're going to leave it there for 7 years, so that means that the time period, always in years, is going to be 7. Okay? And so the question is, what is the value of the account? What is A? That's what we're trying to solve for. And so our formula, if you pull it up, oh, sorry about the bell in the background. Okay. All right, so now that the bell is done ringing 8 times, here we go. Let's plug everything into the formula. The question is, what is A? If I put in a 5,000 for the starting amount, and I multiply it by 1 plus, the interest rate is not 2, it's 0.02 over n, which is 1. That's nice because I really don't need to write that fraction. Raised to the power of n, which is 1, times the time, which is 7. Okay, so now my job is just to be able to simplify this, okay? And so I'm going to do order of operations here. I'm going to work within the parentheses first. I can simplify this piece first. First of all, 0.02 divided by 1 is just 0.02. So really, this becomes 1 plus 0.02 or 1.02 altogether, right? So I have 5,000 on the outside times, it's 1.02 on the inside of the parentheses, and it's raised to the 7th power. It's just 1 times 7, right? Notice the only thing getting raised to the 7th power is the 1.02. The 5,000 comes afterwards, so I do, please excuse my dear Aunt Sally, exponent has to come next. I do not round in any of these bank account problems ever until the very, very end when I'm rounding to 2 decimal places to represent pennies. So if that was like a 1.024379, okay, I would leave all of those decimals, okay? Just keep that in mind. 1.02 raised to the 7th power is this number right here. It's 1.148685668, right? So A is 5,000 times that 1.1486, so on and so forth, right? I'm going to leave ... there, just means that decimal goes on. So I'm going to leave this answer in my calculator. I'm just going to times 5,000. And the answer is, the amount that I have in that bank account is $5,743.43, it looks like, because it's 0.428, so I'm going to round up to 0.43. So we're going to take it out to 2 decimals because that's pennies, and that's what we're used to working with in our money system. Okay, so congratulations, over a period of 7 years, you made a whopping $700, okay, about $100 per year. You're not going to get rich in any of these problems. If I ever do this, I want you to see what, by the way, I just want to show you real quick. If I would have left this as a 2, okay, that would have been 1 plus 2, right? So that would have been a 3 inside the parentheses. If I would have raised 3 to the 7th power instead of 1.02, if I would have raised a 3 to the 7th power, I would have gotten this. I would have taken it times 5,000, and I'd have, like, look at that, $10 million in my bank account. Listen, if you could have $10 million in your bank account by putting in $5,000 and leaving it for 7 years, don't you think we'd all be doing that? Okay, so that should be a huge hint to you. If you ever get a huge number out of your bank account, you did something wrong. Most likely, you forgot to convert that to a decimal. Okay, that makes a huge difference, doesn't it? All right, so let's redo it. Let's do the next problem, and then I'll stop this video and we'll go on to another one. Okay, Last example here in this video. Suppose that the interest in this account compounded quarterly instead. Everything else is the same, but it compounded quarterly. That means that you're going to add interest 4 times per year, or that n is going to be 4. Solve again for the final value. So what is the amount if I put in $5,000? I multiply that by 1 plus still 0.02, 2%, divided by now by 4. And then up in here, it's not going to be 1 times 7, it's going to be 4 times 7. So that's the only difference in the formula. Can we rearrange this? Can we simplify it down? Okay, here we go. We'll get to that inside of the parentheses in a second. Let's do the other stuff first that's easy. 4 times 7 is 28. The 5,000 is still on the outside. What is 1 plus 0.02 divided by 4? It's 1.005. I don't care how many decimals that is, you're going to leave that in your calculator because we're going to now take that and raise it to the 28th power. It's 5,000 now times 1.141498, so on and so forth, right? Dot, dot, dot means that decimal goes on. Okay, so now let's take that value and let's multiply it by 5,000. And we have now $5,749.36 based on this. 0.363, so we leave it as 0.36. So look at that. When they compound the interest quarterly instead of once a year, it looks like you get a little bit more money out of it, a whopping $6 more. Okay, not a huge difference, but hey, you get a little bit more. You can imagine that if they did it monthly, or maybe if they did it daily, then you'd even get more, and you'd gain like an extra, what, 20 bucks, 30 bucks, I don't know. Okay, not a huge amount of money that you're making here. We're not getting rich. But hopefully that makes sense, walks you through a few of the problems. In the next video, we'll talk about continuous compounded interest and a few other applications that are not bank accounts but work the same way.